This is the first video to section 3.4. In this video, we'll talk about the composition of functions. Let's assume that f and g are two separate functions. We are allowed to perform various operations on those functions, such as addition, subtraction, multiplication, and division. Notice for addition, subtraction, and multiplication, the domain of these functions will be the domain of f and the domain of g. However, for the division of the two functions, we have to be careful about the denominator, or g, being set equal to 0. We cannot have 0 in the denominator. So even though x exists in g, it might not exist in f divided by g. Let's do some examples. In number 1, we're asked to first find the f plus g and then state the domain. So we will take f, which is x plus 3, and g, which is 2x squared plus x minus 3, and we're going to add them together. And we'll get this, and then from here, we're going to combine our like terms. Since this is a polynomial, we know that the domain will be negative infinity to infinity. But notice we also know this because for f and for g, these are also polynomial functions, so their domain is negative infinity to infinity as well. Let's move on to f minus g. In this case, we want to be very careful to use our parentheses. And we need to do this because we will have to distribute this negative sign to each of these three terms in g. When we distribute, we'll get this, and then we'll need to combine our like terms. So our f minus g is negative 2x squared plus 6. And this domain will also be negative infinity to infinity. If we want to multiply f and g, again, we'll be careful with our parentheses. Then we'll go ahead and distribute. First, let's distribute the x. And then let's go ahead and distribute the 3. And then when we combine our like terms, we'll get this. Once again, we have another polynomial, and the domain of any polynomial is negative infinity to infinity. Let's go ahead and do f over g, which is the same thing as f divided by g. We need to be careful here because now we have a fraction, and we have to keep in mind that fractions cannot have 0 in the denominator. So when we're figuring out our domain, we have to keep that in mind. Let's go ahead and factor the denominator. Please remember, if you're still having trouble factoring, that's okay, but review your factoring video under the review module in this course. Now, let's be careful and figure out what our domain is. We cannot have 0 in our denominator, so we have to be careful that whatever makes 2x plus 3 equal to 0 is not part of our domain. We also have to be sure that x minus 1, the answer to that, can't be part of our domain. And when we solve this, we don't want x to be negative 3 over 2, and we don't want x to be 1. So our domain will be all real numbers but negative 3 over 2 and 1. And in interval notation, it'll look like this. In number 2, we're given two functions again, f and g, and we're asked to multiply f and g, but solve them when x is 0. There's a couple ways to do this, but what I'll do first is I'm going to find out what the f of 0 equals, and I'm going to figure out what the g of 0 equals. Because once I do, I'm going to easily be able to figure out the f times g of 0. Let's start with the f of 0. That's going to give us 9 for the f of 0. Let's move on to the g of 0 by plugging in 0. And for g of 0, we get -3. So what we need to do is take the two answers from f of 0 and multiply it by the g of 0, and we will get -27 as our answer. And that's the end of the first video to section 3.4.